Good day, this is Professor Will, CBMD PhD. Today is Monday, October 18th, 2021. It is 8:27 and 39 seconds, AM Eastern Standard Time. Today's research, Sun's magnetic forces. So let's hop to it here. How the Sun's magnetic forces arrange gas particles. Date, October 13th, 2021. Source, University of Göttingen. The solar prominences hover above the visible solar disk, like gigantic clouds, held there by a supporting framework of magnetic forces, originating layers deep within the Sun. The magnetic lines of force are moved by ever-present gas currents, and when the supporting framework moves, so does the prominence cloud. A research team has observed how magnetic forces lifted a prominence by 25,000 kilometers, about 2 Earth diameters, within 10 minutes. And this uplift corresponds to a speed of 42 kilometers per second, which is about 4 times the speed of sound in the prominence. Oscillations occurred with a period of 22 seconds, during which positively charged ions of iron were up to 70% faster than neutral helium atoms. The charged iron ions had to follow the movement of the magnetic field, but the uncharged helium atoms are not affected in the same way. In fact, the helium atoms are carried along by the ions, but only partly because there are not enough collisions between the two types of particle, since the gas pressure is too low. In such conditions where partially ionized gas exists, but few collisions play an important role in astrophysics. The role is not just demonstrated in solar prominences, but also in the following: the huge gas clouds, from which stars and planets form, the gas that fills the vast expanse between stars, and then the gas between galaxies. Theoretical physicists have already simulated such conditions as two fluids interacting only weakly with each other. And some of these previous assumptions, used in model calculations, can now be verified thanks to these new measurements and the results. The team carried out the observations of the solar telescope in the laboratory, where it is only possible to measure 2 emission lines simultaneously. In addition, the light intensity for this telescope is increased fourfold, which will enable such a short exposure time for the light-sensitive cameras that even shorter oscillation periods will be measurable. Researchers may then find even higher velocity differences between the charged ions and the neutral atoms. Good day, this is Professor Will, CBMD PhD, on space physics, astronomy, and computer science. This video was created for educational purposes only. Hope you enjoyed listening. Until next time, have a great day.